Hello my lovely students, you are welcome to a new lesson. Today, I shall be teaching you trigonometry. Trigonometry is a branch of mathematics which deals with the study of triangles. In today's class, I shall be teaching you how you can use trigonometry to find the length of an unknown side or an unknown angle of a right-angled triangle. Also, we shall be solving problems involving complementary angles. Let's learn more about trigonometry. Firstly, let's learn how to identify the sides of a right-angled triangle. Although there are different kinds of triangles, our study in this class will involve the right-angled triangle. A right-angled triangle has three sides: the hypotenuse, the opposite, and the adjacent sides. The hypotenuse is the longest side of the right-angled triangle, which is facing the right angle or the 90 degrees. The opposite side is the side that is opposite the angle of reference in the right-angled triangle. In the right-angled triangle displayed here, the opposite side is the side opposite or facing the angle theta. Now, having identified the hypotenuse and opposite sides in the right-angled triangle, the third side becomes the adjacent side. I hope this explanation is clear to you on how you can identify the three sides in the right-angled triangle, talking about the hypotenuse, the opposite, and the adjacent sides. Let's see our first example, talking about how to name the sides of the right-angled triangle based on the angle alpha and angle beta. Here we have a right-angled triangle ABC with the side A facing angle A, side B facing angle B, and side C facing angle C. From the solution, based on the angle alpha, side A is the opposite side because it is opposite our angle alpha. Side C is the hypotenuse because it is opposite or facing the right angle at angle C. Lastly, side B is the adjacent side. Now, based on the angle beta, side B is the opposite side facing our angle of reference, angle beta. Side C remains the hypotenuse in the right-angled triangle because it's the longest side facing the right angle at angle C. This makes side A the adjacent side to angle beta. Next, let's learn about the trigonometrical ratios. We have three major trigonometrical ratios, talking about the sines of angles, the cosines of angles, and the tangent of angles. Here are the formulas for the trigonometrical ratios. The sine of an angle is the opposite side divided by the hypotenuse. The cosine of an angle is the adjacent side divided by the hypotenuse, while the tangent of an angle is the opposite side divided by the adjacent side. We can use the acronym SOHCAHTOA as a quick reminder of the formulas of the three trigonometrical ratios, where SO stands for the sine of an angle is equal to opposite over hypotenuse, CA stands for the cosine of an angle is the adjacent over the hypotenuse, and TOA stands for the tangent of an angle is the opposite over the adjacent sides. Next, let's see an example of how we can find the length of an unknown side of a right-angled triangle. Find the value of x in the right-angled triangle. In this triangle, x is the opposite side facing angle 29 degrees, while 8 is the hypotenuse. The sine of 29 degrees is the opposite side x divided by the hypotenuse 8. To make x the subject of the equation, we are going to cross multiply. That means multiplying sine 29 degrees by 8. This will give us x is equal to 3.88. In this next example, find the height of the plane above the ground. This question involves a right-angled triangle where the angle of reference is 60 degrees, the hypotenuse of the triangle is 1000, and the height of the plane above the ground is h. Do we need sine or cosine or tangent to solve for h? The solution requires the use of cosine because cosine of an angle connects the adjacent side h and the hypotenuse side 1000. Cosine 60 degrees is 0.5. Cross multiplying, our height is 500 meters. Next, let's see how we can use trigonometry to find the unknown angles in a right-angled triangle. In this example, let's find the size of the angle marked x. In the right-angled triangle, 3 is the opposite side to angle x, while 8 is the hypotenuse to angle x. Will this question involve the use of sine or cosine or tangent of an angle? Let's see. From the solution, sin x is equal to 3 representing the opposite side divided by 8 representing the hypotenuse side. From division, sin x is equal to 0.375. X becomes the sine inverse of 0.375, which is 22.02 degrees. In our next example, calculate the value of the angle marked x. Here we have a right-angled triangle with 300 being the opposite of angle x and 400 being the adjacent to angle x. So what do you think we must do to find angle x? From the solution, the tangent of angle x is equal to 300 representing the opposite side divided by 400 representing the adjacent side. From division, tan x is equal to 0.75. X is the tangent inverse of 0.75, which is 36.87 degrees. Moving on, let's learn about complementary angles. Two angles are complementary if they add up to 90 degrees. Please note that in a right-angled triangle, apart from the right angle, the other two angles are complementary angles because they add up to 90 degrees. Next, let's see the complementary angle equations. In the first complementary angle equation, the sine of an angle theta is equal to the cosine of the complementary angle, which is 90 degrees minus theta. In the same vein, in the second complementary angle equation, the cosine of an angle theta is equal to the sine of the complementary angle of theta, which is 90 degrees minus theta. Please take note of these equations. Let's see our final example. Solve the following equations. In question A, sin theta is equal to cosine 53 degrees. While in question B, sin 2 theta is equal to cosine 3 theta. I will teach you how you can solve these equations using two methods. Using method 1 to solve the first question, sin theta is equal to cosine 53 degrees. But from the complementary angle equation, sin theta is equal to cosine 90 degrees minus theta. Equating these two equations, we are going to have cosine 90 degrees minus theta is equal to cosine 53 degrees. Cancelling out the cosine symbols and making theta the subject, we are going to have theta is equal to 90 minus 53 degrees, which is 37 degrees. Using the second method, since sin theta is equal to cosine 53 degrees, that means that theta and 53 degrees are complementary angles. In other words, theta plus 53 degrees is equal to 90 degrees. Making theta the subject of this equation, theta is equal to 90 degrees minus 53 degrees, which is equal to 37 degrees. Next, using method 1 to solve the second question, sin 2 theta is equal to cosine 3 theta, what will be your answer for theta? From the solution, theta is equal to 18 degrees. Here is solving the second question using method 2. Since sin 2 theta is equal to cosine 3 theta, 2 theta and 3 theta are complementary angles. Adding them to make 90 degrees and solving for theta, theta is equal to 18 degrees. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic trigonometry, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.